In this session, we will introduce the spectrum with linear predictive analysis and some basic features of LP method. LP analysis is seen to be a method of short-time spectrum estimation with removal of excitation fine structure, which looks like a form of wideband spectrum analysis. LP spectrum can be obtained by all-pole transfer function and describes the envelope of the Fourier spectrum. When the prediction order P is higher, there will be clearer harmonic structure in LP spectrum. The spectrum of speech segment with short-time Fourier transform when using short window duration is similar to the LP spectrum when the order P is not large. In the example, window length L is equal to 51 samples, which is just the frame length. The prediction order P is equal to 12. Note there are small differences in LP spectral shape between autocorrelation and covariance methods. LP spectrum can approximately represent the speech production system function. The vocal tract model spectrum represents the slowly changing or smooth part of the speech signal spectrum, and the format can be determined. If the prediction order P is large enough, the frequency response of the output model can approximate the signal spectrum with very small error. The larger P in LP analysis, the more number of poles in output model, and the finer envelope of the spectrum. There is the unsatisfactory fit to the values of the spectrum. If we choose a very large value of P, then the LP spectrum will be consistent with single harmonic. In this way, the LPC filter begins to model the sound source, resulting in a poor separation of the sound source and the filter in speech analysis. The plots show Fourier transform of speech segment and LP spectrum for various orders. As P increases, multitudes of the spectrum are preserved. We need to choose a value of P that represents the spectral effects of the glottal pulse, vocal tract, and radiation, nothing else. The speech production model, LPC model, and LPC error model can be described using discrete time system functions. Linear prediction coefficients alpha k are different from the vocal tract parameters ak. There exists prediction error for the AR model. The reconstruction is almost perfect, even if alpha k are not equal to ak. The prediction error signals is also called residual signal in speech coding. The residual signal of unvoiced speech is similar to the white noise. There is no obvious difference in hearing when using white noise instead of residual signal to pass through LPC filter. For the voice signal, the residual signal has pitch cycles. The assumption of output model is not completely perfect. So, although the residual contains the peak values, it is still very different from the pulse sequence. In real applications, if we use a pulse sequence to replace the residue and pass the LPC filter, it will cause the produced speech to sound robotic. That is because real speech does not have a perfect period. it also contains some random components. Another reason is that LPC filter cannot model the zero pose. The error signal of voice speech is good for pitch detection. The error is large at the beginning of each pitch period, and autocorrelation can be performed based on error sequence to detect the largest peak. The error spectrum is approximately flat, so effects of formants on pitch detection are minimized. LP order P affects the prediction error behavior. The larger the p-value, the smaller the prediction error. Normalized prediction error for unvoiced speech is larger than that for voiced speech, because AR model is not quite as accurate for unvoiced signal. Prediction error flattens at around p equals 13 or 14 at 8 kHz sampling rate. For wideband speech at higher sampling rate, the value of p could be higher. One is often interested in identifying vocal resonances independent of the motion of the vocal cords. It is difficult to determine these resonances in the spectrum obtained by using Fourier transforms or bandpass filters. The linear prediction methods take account for resonances directly in the analysis procedure and are thus able to provide a smooth spectrum with well-defined peaks corresponding to the resonances. It is obvious that the harmonic structure in the spectrum introduced by the vocal cords makes it very difficult to identify vocal resonances. The linear prediction methods take account of resonances directly in the analysis procedure and are thus able to provide a smooth spectrum with well-defined peaks corresponding to the resonances. Let's have a summary of LP basic equations. In the analysis part, the speech signal is processed by prediction error filter, inverse filter, and outputs prediction error, residual. In the synthesis part, the error signal excitation passes through output model LP filter and recovers the speech signal. LP parameters can be computed by use of MSE criterion. That's all for this session. See you next session.